All right, hello everyone. Today is our third lesson. It is about physical and chemical properties, page 104 and 105. So let's start with physical properties. We talked about physical properties before. We said physical properties is when a substance appearance changes, but it keeps its identity. What does that mean? It means that the way it looks changes, but it's still the same thing. So if I rip paper, for example, if I take a piece of paper and I rip it, it is a physical property. Why? Or a physical change. Why? Because it is still paper, but the way it looks changed. So the way it looked, which means it got ripped or the shape of it changed, that is a physical property. Melting point is also a physical property. Melting point meaning like when I melt ice. For example, if I put ice on a table, okay, and I leave it on the table, it's gonna become into a liquid because it has a melting point. And also the hardness of anything is a physical property. How hard an object is a physical property. Now, let's talk about chemical properties. Now, we talked about chemical changes and chemical reactions before. We said that it is when two substances, they react together to form a new substance. That is a chemical change. Now, what is a chemical property? A chemical property, it describes the way the material reacted with the other substance. For example, burning. Now, we all know if I burn a paper, if I burn anything, if I burn wood, it is gonna be a chemical change because the wood changes into ashes and smoke and gases, CO2 gases. But what is the property of that chemical change? It is burning. So that is chemical properties. Now, we talked about the reactivity series before, and we're going to talk about it again today. The reactivity series, everyone, is this right here. It shows the metals in order from how great they are to how the least reactive they are. So the greater they are to the least reactive they are. So the greatest metal that we have right here is potassium. Then we have sodium, calcium, magnesium, aluminum. Skip carbon for a minute. We'll come back, talk about it. Zinc, iron, tin, lead, copper, silver, gold, and platinum. So platinum down here is the least reactive, and potassium up here is the most reactive. And it starts from the most reactive all the way down to the least reactive. So we call this the reactivity series. Again, it shows the metals in order of how reactive they are. Now let's talk a little bit about carbon. Carbon, everyone, is a very common element. It is used for a lot of things. We all know the carbon dioxide, CO2 gas, which has carbon in it. Some people mostly they mix up and they think carbon is a metal, but carbon is not a metal. Carbon is a non-metal. But we sometimes add carbon to the reactivity series because it is reactive. It is a reactive non-metal. That's why they add it in between aluminum and zinc. Just keep in mind that carbon is a non-metal. It is not a metal. Now we're going to talk about acids and bases. Alkalis is another name for bases, or it is the most common base. So let's start talking about acids. Acids, اللي هم in Arabic, الحمضيات, okay? They are a group of substances with similar properties. Yani they have similar properties. They all are the same thing in a way. If you look over here, we have some examples. We have stomach acid, اللي هو the acid that's in your stomach, vinegar, fizzy drinks like Pepsi, Sprite, sodas, rainwater, which is the water that comes from the rain. Okay, these are some examples of acids. Also, I have some examples right here. We all know that some foods and drinks have acids in them. Some examples of food is lemon, watermelon. A couple of drinks are sodas and carrots. Okay, something about acids that you have to know is that they have a sharp taste. The taste of it is sharp. Now let's talk a little bit about alkalis. Alkalis is the most soluble base. It's the most base that we use. So we just call it alkalis. It is a group of substances that have a soapy feeling, and it feels like soap. Okay, a couple of examples are soap, hand soap, what you wash your hands with, toothpaste, washing powder, which we use to wash our clothes, hair dye, the one that we use to color our hair, and oven cleaner, any kind of detergent that we use to clean is an alkali. It is a base. Now, we're going to talk about something called an indicator. Now, an indicator is a substance that changes color depending on how acidic or alkaline it is. So it is a material or a substance that we use to tell us if this substance is an acid or this substance is a base. The most common indicator that we are going to talk about, it is called litmus, okay? Now, litmus, everyone, is an indicator. It is paper. So for example, hold on, let me get this. Okay. So let's say that this is litmus paper. It is not, it's regular paper, but I'm just trying to give you an example. Now, if I bring vinegar, for example, and then I put the litmus paper in the vinegar, it is supposed to change its color according to how acidic or how basic it is. Now, before we talk more about litmus paper, let's talk about the pH scale. Now, the pH scale, everyone, it is a scale, okay, that tells us how acidic a substance is to how basic or how alkaline it is. Now, if you look up here, the red, orange, yellow colors are basic, so are acidic, sorry. So from 1 to 6, they are acids. 1 is the highest, that has the most acid, and 6 has a little bit of acid, but it has acid in it. So from 1 to 6, it is acid. Now let's come to 7 for a minute. 7 is known as neutral. It is water, neutral. It's not acid and it's not base, it is in between. Now if you come down here, we have from 8, let's say sometimes 8 goes with neutral, but they consider it a base, but it's like close to neutral. So 8 to 14, it is gonna be basic. Now 14 is the most basic and 1 is the most acidic. Okay, and then it decreases all the way up and decreases all the way down. So for example, I have this litmus paper right here. Now if this litmus paper was put into vinegar, okay, the litmus paper is going to change into this orange reddish color. So when it changes to this orange reddish color, you will know that it is a acid. So for example, if I bring hair dye and I put a litmus paper in the hair dye, you're gonna have a bluish purplish color because it is a base. Okay. Now we are going to talk about neutralization. Neutralization, everyone, is when a substance is neutral. It means that it's not acid or a base. Now, compounds that react with an acid to form salt and water only is a base. What does that mean? It means, or let's say it's not a base, let's say it is neutral. If I bring an acid and I add it with a base, it is gonna give me a salt plus water. Always, always, if you add an acid with a base, your product is gonna be salt and water. Remember, last class we talked about the reactants and the products. The ones on the left, right here, the acid and the base are the reactants, and the salt and the water are the products. So always when an acid and a base, they react together, they give us a salt and a water, sorry. An example of an acid is hydrochloric acid. An example of a base is sodium hydroxide. So when we add hydrochloric acid with sodium hydroxide, they will give us NaCl, which we all know, sodium chloride, which is a salt, plus H2O, which is water. Let's go down here for a minute and talk about most metals also react with acids. This means most of the metals, when they're added with acids, they will react together. When a metal reacts with an acid, it will always give us a salt plus hydrogen. Always our product will be salt plus hydrogen, no matter what the metal and what the acid is. I have an example right here of a metal which is zinc, and we all know that zinc is in the reactivity series. It is in the middle. It is like, it is not really reactive, and it's not reactive at all. It is in the middle. So when we add metal with an acid, and it will give us a salt and hydrogen. Okay, so when metal reacts with acid, it always gives us a salt and hydrogen. The metal that I'm using today is zinc, and I am adding it with sulfuric acid. Sulfuric acid is a type of acid, of course. When they react together, they give us zinc sulfate plus hydrogen. Okay, so that means they reacted together. Zinc sulfate is a salt, H2 is hydrogen. So always when a metal reacts with acid, it will give us a salt and hydrogen. Now the last thing we're gonna talk about today is different materials that have different properties. One material we're gonna talk about today is ceramic. Now, ceramic is either glass or pottery. Pottery means like pots, plates, different kinds of potteries that we use in the kitchen. Even we use them for plants, we use them for sculptures in the house, for different things. So glass and pottery are examples of ceramics or types of ceramics. Now they have similar properties. That means الخصائص تبعونهم, they're the same. They're hard and stiff. Now when something is hard, remember we talked about it, it is a physical property. So ceramic is hard and stiff. It is also heat resistant, means that it not easily becoming hot. Like it gets hot, but it doesn't get hot easily like metals. Okay, and they're also good insulators of heat and electricity. That means they conduct heat and electricity. They attract heat and electricity. Attracting heat and electricity is also a chemical property, and being hard, stiff is a physical property. All right, thank you.